Thank you, Eliska. So a question I'm faced with quite often is this one. How does Axon fit in a microservice architecture? And basically it's how does it relate to microservices and monoliths? And before I go into that, I would like to take a few steps back into basically the birth of a monolith. And we have a very common architecture, which is a layered architecture. And it's very commonly used in almost any of the applications that we see around. And you have these different layers that communicate with each other. So there's a user interface which communicates with the service layer, which then forwards calls to the data access layer. And on the side of it, there's a domain model. In some cases, a rich one, in some cases, an anemic one. And there's some interesting stuff going on there. So we like agile projects, and of course, greenfield projects are very nice as well. And in the beginning, everything is very easy to comprehend and very simple. So basically, we have a domain model that everybody will understand. And as our application evolves, that domain model becomes more complex as we throw more problems at it that it should solve. But the problem with these domain models is that we have different perspectives of looking at things. So different people will see different things. Just as this image, some of you will probably see an old lady, and some others will see a young lady. So it really depends on your probably personal preference or mindset. But this also happens in the domain model. Different people will see different important aspects, and there's different ways to look at your model. And what then happens in a domain model is that it becomes really complex. There's a lot of different aspects involved in this domain model, and everything relates to everything in the end. Fortunately, there's a term for this. There's a pattern for this, which is called the big ball of mud. And we all know that big ball of mud in the end is not about the mud. It's really something else. And in the picture, I think that makes it really clear. And even here, you can see the little architect on top proudly defending his creation. And it's really the same with software development. We have created a big monolith that has no structure, that doesn't allow us to maintain it anymore. There's a pretty clear movement going on right now. I'm not sure if you can call it a trend, but it's the microservices. And basically it's a different way of building applications. And while microservices are being really popular, there's a warning going on as well. And basically Martin Fowler says it really nicely, and he has noticed that almost all the successful microservice stories have started with a monolith that got too big and was broken up. And on the other side, almost all of the cases where he heard of a system that was built as a microservice system from scratch have ended up in serious trouble. And I think this is a very important warning for all of us, that a microservice system is not something you want to build from scratch, right? You want to grow into a microservice system. So how can you do that? So basically, the evolution that we would want is we start off with a very simple application, just a single deployable unit running on our local machine or maybe even in production. And as time progresses, we want to evolve that application. But what we want to do is make sure that we do not end up as a big ball of mud, but instead create a sort of an architecture where we have different components which, when necessary, not any earlier than that, we can split them up into different deployable units. So we can decide to take one of these components and deploy it as a separate unit. And even then, as time progresses, what we want to be able to do is again take one of these units and maybe deploy it once or more than once for replication or scalability or whatever the requirement is that requires us to do so. And that's what I want to talk about today, and how to do that with Axon. For those who don't know, Axon is a CQRS framework for Java. It's open source. It has an Apache 2 license, so basically you can just freely download the source code and modify it as you like. And the goal of Axon is to simplify CQRS-based applications, and it does so by providing building blocks to components that are really common in a CQRS architecture. Now there are a few core principles that Axon Framework is based on, and first of all is message-oriented. So messaging is a very important concept in Axon. So you'll have events and commands being very important building blocks in that. Another very important aspect is location transparency. What we want to do is make sure that components are not aware of the location of any other component that it uses. So it should seem like a component is on another machine, even though it might be on the same one, it might be on the other side of the world. It doesn't tell you anything about the location. And lastly, very important for Axon as well is that it is customizable. So we want you to be able to configure the framework to match your infrastructure instead of the other way around. We don't want to impose any infrastructure on you. So CQRS is a very simple architectural pattern. Basically, it says that you should split an application into two different parts. One part is responsible for processing commands on the screen on the left side, and the other component is responsible for processing queries, basically demand for information. So if you want to change something in an application, you send a command. If you want to know something, you do a query. And there's two different components involved with handling these. And if you use domain-driven design and have domain models, proper domain models, what you will do is have a different domain model for each part of the application. So the command model will have a domain model which is really focused on validating incoming commands and making decisions based on these incoming commands and combined with the current state and defining what should happen in such a case. While the domain model on the query side, also called projections, they're focused on delivering information as fast as possible in the format that is desired by the client. Well, in the command model, it's really important as well to have a very clear separation of different parts of the model. And these different parts of the model should not hold any direct references to each other, because that allows us to split these different models into different components and not having to change any of the business logic that we have. In CQRS or in domain-driven design as well, there's a concept of an aggregate which is really important in this respect. So now that we have split up our command model and query model in different parts, we can also think of the non-functional requirements and how to deal with those differently for each of the parts of the model. So basically, if you have a requirement that you should be able to handle 1 million transactions per second with a response time of less than 10 milliseconds, it will require a whole different modeling exercise than the model that only has 20 transactions per second with a response time of about 100 milliseconds. And the same is, of course, valid for queries. Now, in most applications, if not all, it is quite desirable that any change you make to an application will be at some point visible in a query. So when a command is executed, somehow you want to see the result of that command when you ask the application for information. So we need to synchronize these models, although not predefined by CQRS, but it is the most common approach to use events. And what will happen is that the command model will process incoming commands, generate a number of events, and these events are then published to all the other components, and a component near the projections will update the projections based on the events, so that when you perform a query, it will be updated. Now, all this can happen asynchronously. So you might wonder, what about consistency? How do I ensure that these models are consistent? And basically, you don't. So basically, what you need is eventual consistency. There's no way you can keep a distributed system fully consistent at all time. But what you want is to process commands and make sure that the decisions you make are based on actual state, while what you produce to the user might be eventual consistent data and might be lagging a few milliseconds or worst case a few seconds behind. That is not a problem introduced by this architecture. It's a problem that already exists because information is transported over HTTP. It will take a number of seconds before it's rendered on the screen anyway, and that data might have changed anyway. So in a world where we cooperate on the same data with multiple people, we always have consistency issues. But this architecture just makes it very obvious and clear that we need to deal with it. Another question I always get is about code duplication. So we have these different models, and don't they really look alike? Don't they? Won't they have the same code on each side? And that does not have to be the case. So typically, applications that have that are a good fit for Axon, they will have a certain amount of complexity, both on the command side and on the query side, where on the command side you focus on processing these incoming commands and validating them and defining what should happen. So there's a complete different business logic involved in that component, opposed to the logic that you will find on the projections, where you will focus on the data. So you will update data based on the incoming commands. There's no decisions made. So the code will look very different on that side. And a remark I also have seen a couple of times is, but with this model, with this event-driven model, I cannot see what a change will cause as side effects. I cannot directly in my code see when I produce an event or when I handle a command, how that will affect the queries. And I think this is just something we will have to get used to as the applications that we are going to build and or are building already are becoming much more complex, and they've grown beyond the complexity of what a single human being can comprehend anyway. So we'll have to get used to dealing with an incoming message, producing outgoing message, and just accept that we cannot at that point exactly see how that involves other components. And we have to rely on these other components to produce the correct results based on the events that we emit. And that is, again, of course, the same for any CQRS-based application. So this is what an architecture of a CQRS-based application could look like. On the left, you see the user interface. And the user interface will send commands to a command handling component shown in the top end of your screen. And these commands may or may not have a result. That is a choice you can make. And these command handling components, they act on a domain model specific for that command handling component, which is also stored in a storage dedicated to that command handling component. When that domain model decides something important happened, it can emit an event. And that event is then published to a number of event handling components, which in turn update their domain models, which are there to answer the queries that the UI may do. So location transparency, as I said, it was a very important concept in Axon. And basically the way Axon does that is by separating infrastructure from the business logic and providing APIs to that infrastructure that are location transparent. So on the left-hand side, you'll see a little process diagram which represents the business logic that you have, and on the right side you'll see how that application is being deployed. And initially you want to make that deployment as easy as possible, because you do not want to spend a lot of time building a lot of infrastructure which you might not need at all. So we want to start off small, and in Axon you can define the infrastructure quite easily. If you use Spring, this is the way you could do it in Spring XML. And all you need to do is define, I need an event bus and I need a command bus. And what you get is very simple in-process implementations that allow you to send commands and events in the same thread. Basically, that will allow you to have this single VM implementation. When the time arrives where you need to extract a certain component, and maybe in this case the blue component has to be extracted into a separate VM, all you need to do is change the infrastructure configuration. There's no need for change in business logic because the business logic is location transparent. There's no way you know beforehand where events come from. There's nothing in the API in Axon that will tell you anything about where events come from or where commands go to. So in this case, what we need to do is configure a terminal on the event bus that connects to an AMQP system in this example. So what we can do is we send all the events that we emit to an AMQP message broker, which will then publish all the events to the different nodes. Now again, we did not need to touch any of the business logic code. All we do is say, well, Axon, here's a different configuration for your infrastructure. This is how I want to transport events from the publisher to the receiver. Now, as our little application here become really successful, there might be a time where a certain component has to be extracted again, but also replicated. We might need multiple instances of a certain component running. In this case, the ping component has to be duplicated. And again, all we need to do is change the configuration, and in this case, in this example, we have to change the command bus. And what we can do is choose a distributed command bus, which we connect using JGroups, so that nodes can automatically detect each other and communicate with each other about commands. And what Axon will do automatically is define which node can handle which commands so that it can route them using a consistent hashing strategy. So it can route commands consistently to the same node while the configuration of nodes doesn't change. So that also means that you can use caching really efficiently. You can have an in-memory cache on a specific node because you know that all the commands that will act on a specific part of the model will always end up in the same node until we add or remove any of the nodes. So there's a number of ways how you can interact with Axon, and there's a few APIs that I would like to go into. And the first one is the command handling API. On the bottom left, you'll see how you can dispatch a command message on the command bus. And as you can see on the bottom left, and that part of the code, this is location transparent code. There's absolutely no indication as to whether this command is being sent to a command handler on the same machine or somewhere else. And it may be asynchronous because there's a callback. We don't have a return value. There's just a callback that will be invoked when the command is being handled, but we don't know exactly when. On the other side, all we need to do is annotate a method with @command_handler, and then the parameter of that method will indicate what type of command should be forwarded to that specific handler. And Axon will automatically register that with the command bus and make sure when a component dispatches that specific type of command, it will end up in that handler. Whether it's on the same machine or not, that doesn't matter. On the event bus, it's very similar. Although a command is really dispatched to exactly one component, events are published to whichever component is interested in handling it. So what we can do, again here, is publish an event, and it's a void method. There's absolutely no indication where these events are published. All you say is, I want to get that message out of here, and I don't care how that's being handled further downstream. And similar to the command handlers, all you need to do to create an event handler is annotate a method with @eventHandler, and all the events of that specific type will be dispatched to that specific method, whether it's on the same node or different. That doesn't matter. There's also some support for the domain model implementation. So there's a number of interfaces and also abstract classes that can help you get started by creating a proper model. So the abstract aggregate root for regular aggregates, but also the abstract annotated aggregate roots for aggregates that are event sourced, which we'll cover a bit later. So now that we have all these events in our system, there's a lot of things we can do. So instead of using polling, we can use push. So we don't have to check whether something has happened. All we need to do is just wait for an event, and that is an indication for us that something relevant has happened and we might need to do something in response. Events are a very good way to create a location transparent system because we do not care where an event came from. An event is a simple object, it's a message, and we can really easily transport that message from one node to another and then handle it on the other node. A common use case as well for events is cache eviction. So instead of guessing the time to live on a cache, we can use fact-based eviction. So we can just wait for a specific event to happen that tells us that a cache entry is stale, and we can then evict it based on a fact instead of an estimation of how long data should be kept in the cache. We can also make systems reactive. So instead of polling and instead of pushing each other work to do, we now have an event stream that we can start processing, and an application can, as fast as it can, handle these events, automatically pushing back producers as they struggle handling them. Another aspect that we can now do is create real-time systems. So all we need to do is wait for an event to happen and then respond to it immediately. So we can push events, for example, to front end. So our front ends can also react in real time to what's happening on the server. It also helps us with system integration. So instead of having very difficult components trying to map your domain model to an external domain model, you can use these events and create a separate application that focuses on connecting two systems. That keeps the complexity of such a system out of your own application. And lastly, and that's the one I'd like to focus a bit more on a bit more, is event sourcing. It's a concept that is not really tied to CQRS, although in practice, almost all CQRS implementations that I've seen use event sourcing. And basically, event sourcing is a way of persisting the domain model that you want on the command handling side. So instead of using state storage, what you can do is store all the events that have been emitted by that domain model. And this is what that looks like. So in state storage, you could have two different tables, for example, for orders and order items, and it will give you the current state of things. So in this example, we can see that we have one order with order ID 1 with the status return shipment received. And in that order, we can see that there is one luxury chair. So all we know is one chair was ordered and it was sent back. If we have event sourcing, instead we don't store the current state, but we store all the events that got us up to that state. So we'll have a list of events. Well, the first one is order was created. The second one is we have added 2 chairs to our order. And then later the user removed 1 chair. The user confirmed the order was cancelled, and then the return shipment was received. So here we have information that we did not have in the first scenario, which is that we know that the user has actually added 2 items to his order and then removed 1. And there could be very important business value in these events in the middle. Of course, there are some advantages, but also some disadvantages to event sourcing, and they're very important to discuss with your customer. Quite often, I see developers just choose event sourcing because they really like it and it sounds really cool, and it has some very nice ideas. But then they have to explain later to the business that it also has some disadvantages that the business wasn't aware of. So some of the advantages are quite obvious. One is, well, you have an audit trail, and it's not just an audit trail that is created as a side effect, but it's an audit trail that you use as your own source of truth. So if there is an error in your application, that error will reflect in your audit trail as much as it will in your domain model, which might sound really awkward, but that is what auditors really like. What it also allows you to do is reconstruct query models. So if you find a mistake in your query model, or you need to evolve your your query model to contain data that you did not capture previously, what you can do is empty that query model and reconstruct it based on these events from day one. And that's the third bullet point. It's very similar to that. If your manager comes in and says, I would like to know how many orders we receive each day of the week, if you don't capture that right now, what you can do is just create a new query model, a management report, and feed that report with all the events since day one. So you don't have to tell the manager he needs to wait for your team to implement it and then capture a nice amount of data, but you can go back in time and reconstruct the data. And lastly, you can use an event store for data analysis. So basically, you can do a once-over run of the entire event store and find out if there are interesting patterns, which could be used for fraud detection. But we will also see that in some of the medical domains, there's some very interesting analysis that you can do based on these events. And as I said, there's also some disadvantages, and you have to be really careful with those. Make sure you make a conscious decision for event sourcing. And one of them is, since you store events from day one, and it is an audit trail that you use to reconstruct your own state, you'll have to be able to keep on reading that very first event that you wrote to the event store. So you have to make sure that your application is capable of reading those events. Fortunately, there's support in Axon for that. It's called upcasters, which you can use to make sure that even though you have very old events in your own code base, you do not have to care too much about them. So you can use upcasters to transform the old format to the new one. And another very important disadvantage to keep in mind is that because an event store is append-only, you're only ever going to append new events to the event store, as you cannot undo anything that happened in the past. Your event store will be ever growing. It will always get bigger. And fortunately, disk space also becomes cheaper. So for the same money, you can buy a bigger disk in a few years from now. But it really depends on how fast you're producing events, whether you're going faster than the price drop of disks. But that is something you might want to take into account as well. So if you want to use event sourcing with Axon, that is also possible. There's a number of building blocks that you can use, and the most important one is the event store. The event store is basically the storage engine responsible for storing events. And there's three implementations currently provided in Axon. There's a JPA event store and a JDBC event store, and they allow you to store events in a relational database table. The Mongo event store allows you to store the events in a MongoDB database. Another building block is the abstract annotated aggregate root, which I mentioned earlier, and it helps you create your domain model in such a way that you can use event sourcing on it, because there's a number of things you need to do for that. And basically it comes down to the fact that the command handler method has to be split into two parts. The first part is the part where you make the decision. So it just takes an incoming command as well as the current state of your aggregate, of your model, and it makes decisions. So it decides whether or not, and in this case it's a seed player command, so it makes a decision whether or not that player can be seeded. And if it can, it will apply a player seeded event. So all it does is decide whether or not you can be seeded. It doesn't change anything in the state. The changes in state instead should be done in event sourcing handlers. Basically, they're event handlers, and they're invoked when the apply method is invoked. And the reason we need to separate that is because the current state of this object is reconstructed from past events. And when we apply past events, we do not want to do any validation, because there's no way we can refuse anything that happened in the past. I mean, you can close your eyes to what happened in the past, but that will not change anything. So we should not do any validation. All you want to do there is change the application state. So the apply method will invoke the internal handler, but also register that event for publication. So when the transaction commits, that event is also published to all the other components that might be interested in that specific event. So now that we have our aggregates, when we have event sourcing, all our interaction on that aggregate is done solely using commands and events. So the only interaction with that object is, well, the current state is described as a number of events from the past. The intent that you have is, or the change that you want to make, is a command that you send to that object, and the result of that command is again a number of events that has been produced. So that allows us to create very simple test fixtures that are described completely in terms of commands and events. So given some past events, when I apply a new command, I expect these new events to have been published. And Axon provides a number of fixtures and that you can use to describe that test. Now these commands and events are very typically functional. They have a functional meaning. They use normal business terms. So that means that your test is described in functional terms as well. It's completely implementation independent. So this example, given a number of events from the past, when I do a make call command, I expect the call to have been made and the turn to have been changed. Now, if you're eager to get started with Axon, you can download it. You can go to axonframework.org/download, or simply update your Maven POM files. All the resources of Axon are located in the Maven Central Repository. You can find the code on GitHub, github.com/axonframework. And if you need any help, there's a mailing list that you can send your questions to, axonframework@googlegroups.com. But you can also approach us via Twitter at Axon Framework. Now, just in case you might be wondering, yeah, but what if I use Axon? Will I be the only one? Well, fortunately not. There's a large number of companies already using Axon in very different domains, and there are some implementations that I would never have thought of to have been applicable for Axon. So there's a number of implementation in the finance domain, for example, process automation in top 50 bank, but also pension fund calculations, which is a pretty complex calculation, but also online payment processing. We also see a few applications in the gaming industries, like there's an online bridge platform, bridgebig.com, which has been built using Axon, especially for the scalability features, but also for the very strong auditing requirements. And very similar for the online casino, they have very strict auditing requirements. So they use Axon to make sure that they capture every change in the system. There's also a number of implementations in the healthcare. So if you have dental implants, it might be possible that the tooling that has been used to do that is tracked and traced using Axon. But there's also a number of electronic medical records that use Axon, again for that, for maintaining the history of all the changes and doing very interesting analysis on medical procedures. And an implementation I more recently heard about is in aviation. Apparently Axon is being used to optimize aircraft movement at several large airports around the world. Apparently it's a very complex process to find out where an aircraft actually is, which is not a very comforting thing to know. I'm sorry for that. Fortunately, they were able to connect all these systems based on an Axon-based application. So a little message about the roadmap. We are currently working really hard to implement Axon 3. Axon 3 will hopefully be available in the first quarter of 2016, and it contains a lot of improvements compared to Axon 2. And the most important one is that we are simplifying the infrastructure. So even if you have very large, complex distributed applications, it should become fairly easy to set up an application using Axon, even easier than it already is. What we also want to do is make sure that the domain model you create has less dependencies on Axon. So currently you have to extend Axon classes. That will be removed, so you can create your domain model just in plain Java, have a few annotations, and that should be enough. We also want to improve monitoring capabilities. So Axon is a framework that handles a lot of messages, and these messages are a very good indicator on the health of your application. So it can tell you how fast components are processing events, but also how big the delay is in, for example, the query models, how stale is the data in these models. So we want to expose a lot of metrics from these Axon components, which you can then connect to your own monitoring applications to see how your application is doing in production. Now, since microservices are really taking off, and in the Java world, Spring Boot is a very common platform for these microservices, we also want to provide some auto-configuration capabilities for Spring Boot. So if you use Spring Boot, all you need to do is have some Axon dependencies, and it will use a very default configuration so that when you start off the application without any configuration, it will use certain conventions to set up an infrastructure for you. So it will automatically detect whether you're using JPA or JDBC or maybe Mongo, and then use that for an event store, for example. Axon 3 will also depend on Java 8. So Java 7 and prior versions are no longer supported in Axon 3, and that allows us to use the very nice, for example, Lambda expressions that you can use in Java 8, but also the new stream APIs and things like that to have a nicer API for Axon 3. So from next year, we'll also be providing some enterprise support packages. So basically, Trifork has always been there to help companies achieve their goals using Axon, but we want to formalize it a bit more and tell you about how different ways on how we can help you. One of the ways is an architecture review. So basically, when you have an application that is either just in production or almost going to production, we can help you do a check on the sanity of some of the implementation choices that you may have made, and see if there are things we can improve, preferably before going into production, to make to avoid any complexity. We can also help you in the beginning of a project, help you set up the domain model, because a lot of failures are caused by the wrong choices in domain modeling. There's a lot. Domain modeling is a quite intensive and complex process that you have to get right. Well, you don't have to get right in the first go, but the better you have it in the first time, the less work you have afterwards to fix it. And of course, what we have always done, you can still do that, have on-demand developer support. So if you just have a question and you want to ask us for an immediate solution, we'll be there to answer any questions that you have while you are developing your application. And finally, we'll keep on providing workshops and trainings, both on our premise as well as on any location, for example, in your own company. So basically, that concludes the presentation so far, and I will now give it back to Eliska for questions.